With Solid Edge simulation in ST3, we can further reduce the need for physical prototypes through a wider range of simulation tools. And that's what we're going to take a look at in this particular demonstration using a mower, spindle and blade mounted to what represents the deck of the mower. Now, to begin the demonstration, what we really want to do is reduce the amount of information we're going to actually analyze. In order to do that, I'm going to in-place activate into the spindle part itself. Now, once we're in there, I can turn off the background information. And at this point, what I'd like to do is actually simplify the part or reduce the amount of information on this part that we're going to analyze, as I mentioned. Now, by simplifying models to remove this unnecessary geometry, such in this case as the grooves and the rounds, they really don't have any bearing on the study. So we can get faster simulation results, do more virtual testing, reduce our time to market and costs, and even improve quality. In order to do that, we can go into the simplify mode, and we can actually delete some faces by just fence selecting those faces. You notice they highlight and accept, and it's going to remove that information. We can do the same with the rounds on this part. Quickly fence select, it highlights the rounds and accept them, and it simplifies the model to something a little bit more manageable. Now, when we're done with that, we can go back to the top level and begin our analysis. Now, in this case, we've got a small assembly, and so what I'm going to do is, before we begin, is go to this assembly itself, highlight the part, and tell the system that I want to use the simplified part. Notice now we're looking at the simplified spindle. So let's go ahead and create a new study. Again, using linear static for our study type and tetrahedral for our mesh type. For the geometry, we want to go ahead and fence select our geometry very quickly and add it to the study. Now, I mentioned earlier that we're going to that we offer a wider range of simulation tools. So we can accurately simulate more realistic design scenarios to reduce the physical prototype costs with additional loads and constraints. With the list of loads that we offer, in ST3 we've also added torque and bearing loads. And as far as constraints are concerned, we now offer a user-defined constraint. But in the assembly environment, we still need to tell the system how the parts are connected. And with ST3, we've added bolted connection, which we'll show you how to use here in just a second. But first, let's go ahead and apply a force to the front of this blade. You'll notice I have a steering wheel, which I can quickly change the direction of the force just by selecting one of the knobs on the steering wheel. And I can key in a value. In this case, we'll use 1,000 newtons. And then what I want to do is go ahead and apply a fixed constraint to the spindle and to the side of the blade. When that's complete, the next thing to do is to tell the system how these parts are connected. We have an automatic method or a manual method. I prefer the automatic method. And we can apply a glued or linear constraint. In this case, we'll just use the glued. And I'm just going to select these three components. You'll notice it puts them in a list, gives you the results. So if you want to add to the list, you can, or you can go ahead and accept, and it'll add them to the connections. We still need to tell the system how the spindle connects to the deck. And what I'm going to use is the bolted connection for that option. You'll notice it brings up a quick bar for easy selection of what options you want to use. In this case, I'll use the plane option, meaning I can select a hole on a plane and it'll get all of the holes on that particular plane all in one shot. So you notice how all 4 holes are highlighted. It then automatically picks up the bolt radius, the nut radius, and for pre-stress force, I'm going to go ahead and use a value of 100. And now our bolted connection has been identified. When that's complete, we can actually go to the simulation study navigator, and I'm going to turn off the loads, the constraints, and the connections just to kind of clean up the view a little bit. When we're done with that, we're ready to go ahead and mesh the part. And in this case, I'm just going to use the default meshing value to mesh all of these parts at the same time. I do want to point out, though, that with meshing tools, we do offer the ability to mesh edges, surfaces, or bodies. So you can apply specific meshes to different entities of a part or in an assembly very quickly. And you'll notice here that our mesh is complete. It's meshed all of our components very quickly. The next thing to do is to solve the analysis. Now in this case, we've already ran an analysis to be able to get to this a little bit quicker and save just a little bit of time, and we'll go ahead and look at those results of this analysis that we just set up. You notice it automatically gives us the feedback, and I can easily run an animation tool that animates, in this particular case, this von Mises stress analysis. And you notice right here on the shaft of the spindle, we have a lot of high stress concentration. So we might want to make some changes to this model to strengthen this particular spindle. Now, of course, making design refinements is even faster and easier with synchronous technology. So I'm going to show you how 3D driving dimensions can be used to make precise changes. Live sections can make changes easy, and of course live rules is going to manage our intent as we do this. So what I'm going to do is I'm going to go back into the part file where we have already simplified this part. But what I'm going to do is I'm going to go to the synchronous side and turn off the background information, and I'm going to use a command called live section. Now by selecting live section, all I have to do is identify a reference plane, and it's automatically going to generate a live section of this particular component. I mentioned changing making precise changes to driving dimensions, and we can do that right from our live section. You'll notice when I select a diameter, it gives me the value of that diameter. I can either scroll a new value, or I can key a value in. In this case, let's do a precise 60 millimeters. And we can fatten that spindle up a little bit. By using the steering wheel, I can drag to a new value, or I can also key in a value. And then finally, let's beef up the bottom part of the spindle by making a change to it. And in this case, we're going to go to 40. When that's complete, you'll notice that Live Rules down here is managing all of our intent to make sure that the model maintains integrity. And when that's complete, we can close and go back to the top level of our assembly. And you'll notice that the simplified model automatically updates to those changes. So the final thing to do is to actually rerun the analysis to pick up the changes that we've made. And in order to do that, we've already set that up as well. And we'll go into the finish study for number 2. And as we go to that, you'll notice that the results show that our spindle is much, much stronger. You'll also notice where the stress is on where the bolts are connected to the deck. Again, we have the capability to animate and run the animation. In fact, within the results environment of simulation, we offer several tools to change the display of what you're looking at to get the correct feedback that you're looking for. More importantly, it might be important for management to see a report of this analysis. So when I click on the report, it's going to bring up the Create Report dialog where you can key in the report title, the author, the company, introduction, conclusion, that type of information. But in ST3, we also now offer the capability to create Word documents and PDF files. In this case, I'll go ahead and create a Word document. It's going to take a snapshot of the different results, in this case displacement and stress, and then it's going to build that Word document for us. And here we can see that Word document. So if I go over, for example, to results, it'll take us down to the results section. So those are live links that'll take us throughout this document and give us great feedback and accurate information from the analysis. So again, with Solid Edge ST3, you get engineering simulation for real-world conditions. Better tools for better output. I hope you've enjoyed this demonstration.